Excuse me. Hey, hello, welcome. Here we go again. Another set of notes for you to copy and learn and gain some wisdom. We're going to talk about inequalities in one triangle. Today, you will recognize and apply inequalities to the measures of the angles of triangles and apply properties of inequalities to the relationship between angles and sides of triangles. Yippee-ki and yay. Okay, so what do we got to say? I want to remind you something here. And they start off in the book with something talking about this. If A is, and trust me, their wording is so much longer. But look, the idea is important. If you know a number is equal to the sum of two other numbers, A is equal to B plus C, then A, the one that was equal, is going to be greater than either of the two individual ones. A is going to be greater than B, and A is going to be greater than C. More specific example, we know 5 is equal to 2 plus 3. Thus, we could say 5 is greater than 2 and 5 is greater than 3. Well, that sounds like a duh, sir. I know that. Well, trust me, there's a reason why I do this. Okay. And then there's some key concept properties of inequalities that you might want to remember here. I am not going to put a huge focus on it here. This should be like common sense stuff. Ooh, really got a frog in my throat today. All right, so what does Theorem 5.8 say? Theorem 5.8 says, and we're going to back this up a bit. The measures of an exterior angle of a triangle is greater than the measures of either of its corresponding remote interior angles. Okay, so this comes back to this, and this is something y'all kind of seem to have missed. I mean, should be a simple concept. If you have a triangle ABC, you have an angle A, you have an angle B, and you have an angle C. Now, at some point, we said this exterior angle right here, there's a line that I'm drawing straight off this triangle. I can do that off any of the vertices, to be honest. But straight off. That exterior angle is equal to the sum of the other two angles. In other words, has nothing to do with one, but if you add angle A and angle B, you would get angle 1. Okay, so the measurement of angle 1 is going to be greater than A, because since both A plus B equals 1, angle 1 is going to be greater than A, and it's going to be greater than B. That's what that theorem is basically stating. That one exterior angle is going to be greater than either of the two interior angles that is not next to it. Okay, and again, the reason why is because A plus B would have been equal to 1. Okay? All right, so let's do an example. I want to find all of the angle measures that are greater than 7. Oops, went a little too far there. Okay, so notice that 7 is an exterior angle. So, if 7 is, that are less than 7. I said greater than, didn't I? Never mind, let's try that again. List all the angles, not angle, but angles, whose measure are less than 7. Okay, so 7 is an exterior angle. That means there's two interior angles that it is bigger than. For sure, because those two interior angles, those two angles inside the triangle are going to add up to angle 7. So if I look at the small triangle, like that one right there, KML, then I know angle 4 and angle 5 are going to add up to angle 7. Because again, the two interior would add up to that exterior. So since those two add up to 7, angle 4 is going to be less than 7, or 7 is going to be greater than that, and so is angle 5. Okay, that one's easy. Now, let's look at the big triangle. Oh, there was more to this? Yes, of course there was. So now let's look at the big triangle. I know that, let's say here, angle 1, and this one right here, JKL is going to add up to angle 7. So I can easily say angle 1 is going to be less than angle 7, or 7 is going to be greater than it. And I know for a fact that angle 2 and angle 4 add up to JKL, and I've already got angle 4 noted. So if angle 4 is less than 7, 2, which has to add up with 4, and then add that to 1 to be equal to 7, has to be less than 7 also. So there are my 4 angles that I know for sure are less than angle 7. Okay, let's change this up a bit, and now let's go greater than angle 6. Okay, now notice angle 6 is inside the triangle. So to know for sure that there's something greater, it has to be an exterior angle, because that's all I've got here. Okay, but angle 7 is right next to it. So I can't really assume that. I mean, I know it looks like 6 is acute and then 7 has to be obtuse, but based on what we've got. Okay, so if you look at the small triangle again, then you've got here this little line. If I extend it just a wee bit further, that creates an exterior angle to the KML triangle. So that means then that angle 3 is an exterior angle. And if that's the case, then angle 3 has to be greater than angle 6, because angle 6 plus angle 4 would equal 3. You see, because again, these two here add up to that one exterior. That one exterior. Okay? So that means then that angle 3, I killed it. Okay. That angle 3 is going to be greater than angle 6, because again, 6 plus 4 has to equal to 3. Okay, so that covers the small one. That's it, because you only can look at exteriors. And again, angle 7 has to deal with like that being 180 degrees. And again, I know based on the look, but we're going based on what we know for sure. Not just based on look, by using properties. Okay, so now let's look at the big triangle. So if I look at the big triangle, okay, let's try that again. Big triangle, so JKL, then I see here there's an angle 8. That's an exterior angle. Now, what would add up to 8? Angle 1 plus angle 6 would add up to equal angle 8. Okay, again, two interiors add up to the exterior. If that's the case, then I know that 6 is less than 8, because 8 is going to be bigger than 6. So then angle 8 is also greater than that. And that's it. That's all you can do, because those are the only exterior angles you can find from the two that are shown there in the drawings. All right. Ooh, I'm taking up a lot of time here. Let's move on to the next thing. I have no idea what happened there. Okay. So the next part is we're going to talk about angle-side relationships. I'm not going to spend too much time on this because it's pretty self-explanatory. If one side of a triangle, you can see the theorems. The theorem is basically saying that if you have one side, okay, remember, the side opposite of an angle corresponds to that angle. So if this side is longer than, say, this side, xy is longer than yz, then angle z is going to be greater than angle x. That's all that's saying. Same thing if an angle has a larger measure. Since this angle is bigger than this one, that means the side opposite it, this side, is going to be greater than the side opposite the shorter one. Okay? What does that mean? Well, let's see. Okay, so here I want to take a triangle and I want to put the angles in order from least to greatest. We'll start off with something easy. Okay, so if you look, you can tell the sides are, we have, in order from least to greatest, shortest to longest, we have the 7.5, which is PR, the 8.8, and the 9.1. That's in order from least to greatest. Now, what angles correspond to that? Okay, the 7.5, which is shortest, goes to angle Q. Remember, it always goes to the opposite angle or opposite side to opposite angle, so on and so forth. So that means angle Q is going to be my smallest angle. The next one, the one in the middle, is that 8.8, which corresponds to angle R. So that one's going to be there in the middle. And then finally, the 9.1 corresponds to angle P. So there you go, just like that. Now, what's the other example? Let's look. Here I make you do a little bit more work. Here we want to list the sides from shortest to longest. But before we can do that, we got to find the third angle. So we got to find angle F, which means you need to add 45 and 56. You get 101. And then we know that all triangles add up to 180. So if we subtract from 180, we get 79. So that means there we have 79. Now we know in order we have angle G, angle H, and then angle F. So how do I find the sides? Well, opposite the 45 is side FH, so line segment FH. Opposite the 56 is FG, so FG. Notice how I'm writing those answers. And then finally, opposite 79 is GH, so there you go. And that would be listing all the sides in order from shortest to longest. Anyways, I'll go ahead and stop there. We're done for today. Want to make sure you're good. Let's go ahead and do something a little Christmassy. If you put there Santa at the top of your notes and show it to me, I'll add some points for your next test. Okay? Don't forget, the magic word there is Santa. And thank you so much for your time. Y'all take care.